Okay, good morning students. Okay, in the last video we have seen how to draw the influence line diagram for a shear force at a given section of a girder. So today today we'll see the numerical based on that one. It is very simple. Okay, so find the shear force at the section K for the loaded girder by the method of influence line. Okay, and the numerical is like this. So we have girder of span AB and the load we have 70 kilonewton, 60 kilonewton, 50 kilonewton. Okay, so there we have 2 meter, 3 meter, again 3 meter and 4 meter. Okay, and the section K is at this position. Section K is at this position, which is 1 meter and 2 meter from this loads. From this load, okay, 1 meter and 2 meter. So simple, draw the shear force ILD for the shear force. That means it is a combination of reaction VB and VA. So first I will draw ILD for VA. This is positive diagram on the upper side of this line. Now this one is a negative diagram. That is support reaction VB diagram. This is unity, and we have section at this position. Section at this position. So that means, so what we have, this is what the area comes under the calculation, okay. Now for the load, so we'll take here the projection of this load here, here, here. So this one will be what? So what is the total span? Okay, 12 meter, correct. So what is here? 2 by 12. This one will be 5 by 12, correct. So 5 here will be 6 by 12. Now this is on the B by L, so this will be 2 plus 6 by 12. Again this will be 4 by 12, 4 by 12, sorry, 6 by 12, 4 by 12, correct. Now what we have? SK, that is a shear force at a section K, so what will be the, now this is negative and this is what the positive, this is what the negative, this is what the positive. So what is the load? 70 into or net. Now or net is minus diagram, so minus 2 by 12 plus load 60 or net minus 5 by 12 plus load or net 4 by 12. Now it is a positive, 4 by 12, 4 by 12. So what is we have? Minus 20 kilonewton. So the shear force at section K equals to minus 20 kilonewton. Minus 20 kilonewton. So here, so you can see the use of this influence diagram. here not required to calculate the reactions Va and Vb. Okay, not required to draw the diagrams, not to do the shear force calculation. So it is very simple if you know the influence line diagram for a shear force. Okay, just you draw the shear influence line diagram for the shear force. Okay, then where there is a section, you consider the left negative part. Okay, left diagram. Now see here, so this is what we have a section, so you consider the net left diagram, that is a negative diagram. On the right hand side you consider the positive diagram. Okay, so we have seen in the last numerical why it is negative and positive you have to consider. Okay, so negative, positive. Now it is very simple. Load into the ordinate, load into the ordinate. You see this ordinate is on the negative diagram or positive diagram, so give the sign convention for that one, you will get the shear force. So it is very simple to find out the shear force at a given section, at a given section, at a given section. Okay, so that we have seen for this point load. Okay, now we will see for the UDL. If there is UDL, okay, so how to find out. Okay, find the shear force, find the shear force at the section K, section K, for the loaded girder shown in figure. Okay, now we'll see the girder. So this is what the girder. Now this is girder. Okay, at 1 meter we have UDL of intensity 80 kilonewton per meter. Okay, and the span of girder is 3 meter. And also we have point load of intensity 90 kilonewton, is at 1 meter and 2 meter. Okay, so total span 3 plus 3 7 meter. Total span is 7 meter, and the section is at given is 3 meter from the left support and we have 4 meter. So this is what the section XX. So we have to find out what is the shear force at a section X, that is we have to find out the shear force at a 3 meter from the support A. Correct. So again you draw the influence line diagram for the shear force. You draw the neutral line, draw the for the reaction BA, this is unit, and draw VB. Now see here, section is this one at this position. So you consider, so this is what the positive diagram, this is what the negative diagram. So you consider the negative diagram portion and the positive diagram portion, right hand side. Correct. Now so just I will have the projection here, one projection of this UDL, here one projection of this UDL, and the projection of this point load is this one. So this one will be 1 by 7, this will be 3 by 7, this will be 4 by 7, this will be 3 by 7, this will be 2 by 7. Correct? Now we know for the UDL, intensity into area under the load. Intensity and the area under the load. Correct? Intensity into the area under the load. So what is the reaction? So I will do the calculation here. So the SK, that is the shear force at a section K, that is K equals to, so what is the intensity is 80, correct? It is 80. Now I will take in bracket, what is here, 1 by 7 plus 3 by 7. What is height? So this one is what, how much, 2 meter, only 2 meter, one gone 2 meter into minus, because this minus diagram, so minus 2 by 2, minus 2 by 2. This is what the first calculation. Now plus, now this one, so what is the intensity, 80 in bracket 4 by 7 plus 3 by 7 into, now it is positive diagram, for this is for VA, so plus, so height is what now, so this is what 2 gone, only 1 is now 1 by 2. Now plus, this is load 80, or net is 2 by 7, plus, it is plus diagram. So this is what the total shear force. Okay, so this must be equals to plus 20 kN. So this is about this, the shear force calculation at a given section. If you know this ILD, that is the shear force, ILD for the shear force, ILD for the shear force. Okay, simple. Okay, so it is very simple. Okay, so we'll stop and we'll see in next lecture and next numerical in the next video.